Okay, so just to wrap up this discussion of MapReduce versus databases, I want to go over some results from a paper in 2009 that's on the reading list where they directly compared Hadoop and a couple of different databases and see if we can maybe explain what some of these results tell us. Andy Pavlo and some other folks at MIT and Brown who did an experiment with this kind of a setup. So the comparison was between three systems: Hadoop, Vertica, which was a column-oriented database, and RDBMS X, which shall remain unnamed, although you might be able to figure it out. And so we haven't learned what a column-oriented database is and what a row-oriented database is, but we may have a guest lecture later that will describe that in more detail. But for right now, for the purposes, just think of these as two different kinds of relational database, or two different relational databases with different techniques under the hoods, under the hood. Okay, and so there's two different facets to the analysis. One was sort of qualitative about their discussion around the programming model and the ease of setup and so on, and the other was quantitative, which was performance experiments for particular types of queries. Okay, so the first task they considered was what they call a Grep task, and so this is a task to find a 3-byte pattern in a 100-byte record. And the data set was a very, very large set of 100-byte records. Okay. So this was done this task was performed in the original MapReduce paper in 2004, which makes it a good candidate for a benchmark. And so the data set here is 10 billion records with, totaling 1 terabyte spread across either 25, 50, or 100 nodes. Okay, so you're just trying to find this record. So this is much like this genetic sequence DNA search task that we described as a motivating example for sort of describing scalability. Okay. Fine. So what were the results? Just to load this data in, this is what the story sort of looked like. Hadoop and the system called Vertica, that they're really the theme here is they were the designers of the Vertica system. And so most of these results are going to show Vertica doing quite well for a variety of reasons. So we're not going to talk too much about those particular reasons. We're mostly going to be thinking about RDBMS X, which is a conventional relational database, and Hadoop. Okay. So here, loading is fast on Hadoop, while loading is slow on the relational database. And again, it was sort of fast on Vertica as well. So why is it faster on Hadoop? Well, there's not much to the loading, right? You have to put it into this HDFS system, so it needs to be partitioned, but that's about it. When you put things into a database, it's actually recasting the data from its raw form into internal structures in the database, and that takes time. Okay, and the process could be even worse because if you're building indexes over the data, you actually, every time you insert data into the index, it needs to sort of maintain that data structure. Okay, and so load times are known to be bad. So the takeaway here is remember that load times are typically bad in relational databases relative to Hadoop because it has to do more work. Now, once it's in the database, you actually get some benefit from that, and we'll see that in a second even in these results. But it's actually, we know that it conforms to a schema, for example. Hadoop is just a pile of bits. We don't know anything until we actually run a MapReduce task on it. Okay. And so how much faster? Well, in their experiments, on 25 machines, we're up here at 25,000. These are all seconds, by the way. 7,500 seconds versus 25,000, and a little bit less as we go up to more servers. Okay. Now, actually running the Grep task to find things, this is what we see. Again, maybe ignoring Vertica for now, because I haven't explained to you what the difference about Vertica is that allows it to be so fast. But just think about a relational database from what we do understand. Hadoop is slower here, and the primary reason is that it doesn't have access to a index to search. So Hadoop is slower than the database, even though both are doing a full scan of the data. The grep task here is not something amenable to any sort of indexing. You actually have to touch every record, so there's no fundamental reason why the database should be slower or faster. But partially because it gets a win out of the structured internal representation of the data and doesn't have to reparse the raw data from disk like Hadoop does. And there is a fundamental reason, because it's already in a kind of a packed internal binary representation, which we paid for in the loading phase, but now we get the benefit from here in the query phase, even before we even talk about indexes.